Hi everyone. Today we are going to learn about the RS configuration of some simple molecules. How we can assign a configuration, RS configuration for simple organic molecules. We know that the chiral compound is much important in today's drug discovery field. So for that kind of chiral compounds, we can assign the configuration R or S. How we can assign the configuration of some simple molecules can be learned from this video. Let us start the session. For assigning the RS configuration for some chiral compound, we should follow the CIP rules. The CIP rules is Kahn, Ingold, Brilla rules. By following these rules, we can assign the RS configuration very easily. It consists of only two steps. The first step is the four atoms or groups which are attached to the chiral carbon atom has to be assigned priorities according to the sequence rule. The sequence rule is when four different atoms or four different groups are attached to the chiral carbon atom, the priority depend upon the atomic number of the atoms which are directly attached to the chiral carbon. In case among the four, the atom which higher atomic number having the higher priority. In case of isotopes of same element which are attached to the chiral carbon atom means, that is, in a chiral carbon atom, we are having both hydrogen as well as the deuterium. That is isotope of same element. In that cases, the higher priority goes to the isotope with higher mass number. Some examples are shown here for the decreasing order of priority is shown here. Iodine is having more priority among the halogens. Iodine, bromine, chlorine, then SH, then F, then OH, then NH3. All these things are depending upon the atomic number. And the sequence rule 2 is if the rule 1 failed to decide the priority of atom or group which are attached to the chiral carbon, the priority can be determined by comparing the next atom. When a chiral carbon is having four different groups, among the four different groups, if two or more than two atoms or groups are found to be having same connecting atom. That is, look at the examples given here. This is propyl group. This carbon is attached to the chiral carbon. This is the isopropyl group. This is the carbon attached to the chiral carbon. Both the groups are having the attached atom is found to be carbon. So in that case, we have to assign the priority according to the next atom. So the carbon is attached to the chiral carbon is having one hydrogen and two methyl groups. Here in this case of propyl, the carbon attached to the chiral carbon is having two hydrogen and one ethyl group. So on default, these isopropyl group is having the higher priority. The another example is if the molecule is having methyl as well as the ethyl, the methyl group is having lesser priority than the ethyl, because here carbon is having 3 hydrogen, but the attached carbon here in case of ethyl, we are having 2 hydrogen and 1 methyl group. Similarly, this OH, when OH is compared with the ethoxy group, here OH, the attaching atom is OH. In case of third example, it is OH. In this case, it is O. In case of OH, along with the O, we are having only 1 hydrogen. But in case of ethoxy, we are having 2 hydrogen and 1 carbon. So this ethoxy group is having more priority than the OH. So by using these two sequence rules, we can assign the configuration according to the atomic number. So by using these atomic number of 4 different atoms or groups attached to the chiral carbon, we can assign the configuration. Here, let us consider this example. This is the chiral carbon. The chiral molecule is shown in the Fischer projection formula. We can assign the RS configuration both in the Fischer projection as well as the wedge-shaped projection also. This is OH, this is CH2OH, this is hydrogen, this is CHO. By using these two sequence rules just we have learned, so we can assign the priorities. Here the carbon is attached atom to the chiral carbon. Here it is oxygen, here it is carbon, here it is hydrogen. So when coming to the sequence rule 1, among these 4 directly attached atoms, oxygen is having more priority, so it is having the priority number 1. When coming to the second priority, the next 2 atoms are found to be carbon. Here, the carbon is in the form of aldehyde, that is C double bond OH. Here it is in the form of CH2OH, it is in the form of primary alcohol. Here the carbon is attached to 2 hydrogens and 1 oxygen. So in this kind of compounds, we can have one more rule. What is the third rule? That sequence rule is a double bond or triple bond is equivalent to 2 or 3 such atoms. Here aldehyde group CHO means this carbon is attached to the double bond O. It can be considered as 2 oxygen atoms. So CH2OH is considered as OHH. So when using these sequence rule, we can assign the priorities priority number 2 for aldehyde, the priority 3 for the CH2OH, and the priority 4 for hydrogen. And these sequence rule 1, this is the first sequence rule, second sequence rule, and this is the third sequence rule. When after that, the second step. In the first step, we had seen the 3 sequence rule. After that, the second step. When all the priorities of 4 atoms or groups attached to chiral carbon have been decided. Once a priority is assigned, the molecule has to be visualized from the lower priority is directed away from us. That is, the lower priority group, whatever it may be, either it may be a hydrogen or some other groups, whatever it may be, but the molecule to be visualized in a way that the lower priority group is far from us. So when we are looking the molecule, we have to look at the arrangement of the remaining atoms. The lower priority, that is, among the 4 atoms, the 4th priority group is away from us. And the remaining 3 priority groups, we have to visualize. We have to travel. I have to travel in the priority sequence 1, 2, 3. If the I rotates, that is the I travels in a clockwise direction, that is 1, 2, 3, in a clockwise direction. In a clockwise direction, the configuration, the molecule's configuration is found to be R. If the I travels in anti-clockwise, 1, 2, 3, the configuration is known as the S. Here an example is given. The highest priority is 1. The second priority is aldehyde group. The third priority is CH2OH. Fourth priority is hydrogen. The fourth priority is hydrogen. Okay. We have to look at the direction, whether it is a clockwise or anti-clockwise. We have to look at for 1, 2, 3. 1, 2, 3, it is known as anti-clockwise direction. So we are expecting yes. Here, in case of Fisher projection formula, when lower priority group is in the horizontal line, this kind of horizontal line, we have to give the opposite configuration. Similarly, in wedge-shaped projection formula also, the lower priority group in the dash line. So otherwise, if it is in the solid line, means we have to give the configuration oppositely. Whatever you are getting, we have to give that opposite configuration. If you are getting the R configuration, I have to report it as S. If I am getting the S anti-clockwise direction, S means we have to report it as R. Likewise, in the Fisher projection, if the lower priority group is in the horizontal line, we have to give the opposite configuration. Even though it is found to be an anti-clockwise direction, yes, we have to give it as configuration R. This is one of the rule. Let us see the examples how these R and S configurations are assigned for some simple molecules. This is the example number 1. So we can assign the priorities now. The first priority goes to the CH2OH. The second priority is ethyl. Third priority is methyl. And the fourth priority is hydrogen. By default, the fourth priority, that is the lowest priority, is in the dash line. So no problem. So when coming to these 3 priorities, how we have assigned? This is C. This is also attaching carbon is C. This is also C. So we have to go to the next atom. There is hydrogen, 2 hydrogens, 1 oxygen. Here 2 hydrogens, 1 carbon. Here all the 3 are hydrogens. So by default, the most highest priority should be given to this alcoholic group, and the second priority is for ethyl and third priority for methyl. So what could be the configuration? How the I gets traveled from 1, 2, 3. So it is in the form of the clockwise direction. So it is in the form of the clockwise direction. So we can get the configuration R. It follows the clockwise direction. Lowest priority group is also in the dash line. So we can assign the configuration as R. This is the first example. Likewise, we have to assign the RS configuration for all the molecules. We can assign. The next example is this one. So we can assign the configuration for this. Before that, we have to assign the priorities according to the atomic number. Here it is CH2F, there is CH2, CH3, this is methyl group. So when comparing with the first atom, all the carbon atoms are all are carbon atoms. So we are not able to assign the priority. When coming to the second atom, connecting atoms, 2 hydrogens, 1 F for this molecule. Here 2 hydrogens, 1 carbon for this substituent, and here 3 hydrogens. So we are giving the most priority to this CH2F. This is the second priority. This is the third one. The fourth priority, lowest priority, is at the dash line. So here we have to look at the travel of I, whether it is in the clockwise or anti-clockwise. So here in this molecule, it is known as clockwise direction. So by default, the configuration is clockwise direction, means it is R. So likewise, we can give some more examples also. Here, let us consider this example. We can assign the priorities. This is 1, this is 2, this is 3, and this hydrogen is 4. But what is happening here? The lowest priority is not in the dash line. Even though the molecule is Visualizing from the lowest priority, it gives a configuration as clockwise direction. We are expecting that it to be R, but it is not R. Because as we are having the lowest priority group in this solid line, solid dash line, so we have to give the opposite configuration what we are actually getting. So we are actually getting a clockwise direction R, but due to the presence of lower priority group in the solid line, so we have to report it as yes. So the configuration for this molecule is yes. And then the another example is OH, CH3, an alkene group, and hydrogen. The priority goes to molecule like this. This is the first priority, this is the second one, third, and fourth. Here, the lowest priority is in the solid dash line, so no problem. So when coming to the eyeball movement, the molecule travels from 1 to 3. So it is an anti-clockwise direction. So 1, 2, 3 anti-clockwise direction. So we are having the configuration is yes. And the next example is in case of the Fisher projections. The same kind of assigning the priorities and then the eyeball movement, whether it is clockwise or anti-clockwise. Clockwise means or, anti-clockwise means yes. If the lowest priority group is in the vertical line. If the lowest priority group is in the horizontal line, we have to give the opposite configuration as we had seen in the sequence rules, Koninkal-Prelog's rule. So now we can assign the priorities to these molecule. This is the number 1 priority as both these atoms are carbon, direct attached atoms are carbon. This is the oxygen. So when coming to the highest atomic number among these three is found to be OH. So this is the first priority. And this is the second priority and this is the third priority. This is the fourth priority. When coming to the eyeball movement, 1, 2, 3. So the rotation goes on like this. It is found to be clockwise direction and the lowest priority group is also in the vertical line. So we can assign the priority as such what we are obtaining. So this is the R configuration. When coming to this molecule, when we are assigning the priorities, the directly attached atom here it is found to be nitrogen. So it is having a higher atomic number than the carbon atoms attached here. So this is the highest priority. This is the number 2 priority. This is number 3 and this is 4. When coming to the eyeball movement 1, 2, 3, it is said to be a clockwise direction. But in this case, the lowest priority group is in the horizontal line. So even though it is found to be an clockwise direction, we are expecting our configuration, but it doesn't like that. It is an S configuration due to the presence of the lower priority group in the horizontal line. So we have to give the opposite configuration. The other examples are shown here. According to the priorities, the molecule goes in the clockwise direction. We are expecting the molecule goes in the anti-clockwise. 1, 2, 3. Anti-clockwise, we are expecting as yes, but due to the presence of lowest priority in the horizontal line, we have to give the opposite configuration, that is yes. And the next example is this. Among the halogens, bromine is having more higher atomic number, so it is the highest priority, this is the second priority, and this is the third priority, this is the fourth priority. So 1, 2, 3, clockwise direction. We are expecting it to be an OR configuration, but actually it is yes configuration because the lowest priority is in the horizontal line. And this is the special case that as of now we had seen that the RS configuration assigning for a chiral compound with one chiral center. Hereafter, we are going to see how we can assign the RS configuration for molecule having two chiral carbon atoms. This is a chiral carbon. This is the another chiral carbon atom. So when working on these kind of molecules, we have to assign priority for first carbon for one chiral carbon. So according to this chiral carbon, this nitrogen is found to be the first priority. This is for second priority. And these rest of the molecule is considered as third group. Okay. We have to follow here carefully. So when coming to consider this chiral carbon atom, the highlighted chiral carbon atom, the spotted carbon atom, the connecting atoms are nitrogen, carbon, hydrogen, and the rest of the molecule is considered to be as a group, one group. So this is also a carbon connecting atom. So among these four, this nitrogen is found to be number one priority. This is number two priority. This is number three priority. These full group, the highlighted blue color highlighted groups is known as third priority. And this hydrogen is known as fourth priority. So similarly, we have to consider it for this spotted chiral carbon also. Here, by assigning the priorities for this chiral carbon atom, this is number one. Even though this is carbon atom, this is carbon atom, the connecting atoms is found to be only 3 methyls here. And for this carbon, connecting atom is nitrogen, carbon, hydrogen. So this is getting the higher priority, number 2, and this is the number 3 priority, and this is number 4 priority. Here, for this molecule, for this chiral carbon, the molecule is found to be 1, 2, 3. It is shown here 1, 2, 3. That is highlighted in the pink. The pink highlighted letters, the rotation is shown in the pink color arrow mark. So it is known as clockwise direction. We are expecting it as R, but actually it is yes. Similarly, in the third carbon, we are expecting that it is 1, 2, 3. So we are expecting anti-clockwise, yes, but it is actually R. So the configuration at the second carbon is 2s, and the third carbon is it is R. Similarly, we can have some other examples also. We know that it is an example of tartaric acid. In this tartaric acid, how we are going to assign the RS configuration, which are having 2 chiral carbon atoms. So when considering this chiral carbon atom, the connecting groups are OH, acid, hydrogen, and these molecule as a single moiety. As such, we are expecting the assigning priorities. And for this chiral carbon, and for this spotted chiral carbon, the priorities are assigned and highlighted in the blue color. So when coming to the assigning the configuration by using the priority, it shows that for this spotted carbon, the priorities are highlighted in, shown in the pink color. So the priority goes like 1, 2, 3. That is anti-clockwise. But what happened to the configuration? It gets opposite configuration because the hydrogen is in the horizontal line. The lowest priority is in the horizontal line. So we are expecting the R is getting shifted to the S. When coming to the second chiral carbon atom, here the configuration is, the priority is 1, 2, and these things are found to be 3. 1, 2, 3. So it is found to be a clockwise direction, but hydrogen is in the horizontal. So automatically it gives R. Here comes the another example. So for this chiral carbon, the priorities assigned are like this. This is number 1. These bulk group has 2, this methyl has 3, and this hydrogen has 4. Similarly, in the next chiral carbon, The priority is assigned like as shown here. Number 1, this bulky group has 2, this methyl has 3, this hydrogen has 4. So the priority is 1, and then these bulky group has 2, this methyl has 3. So 1, 2, 3. So it is in the anti-clockwise direction. We are expecting it as yes, but in case of hydrogen in the lowest priority group in the horizontal line, it is considered as R. And for this molecule, sorry, for this substituent, this chiral carbon, the priorities are 1, this whole group has 2, and this is 3. So 1, 2, 3. Anti-clockwise direction, we are expecting it as yes, but hydrogen is in the horizontal line. We have to give it as opposite configuration R. So both the chiral carbon is having the R configuration. This is another example. The priorities can be assigned according to the priority rule as seen before. This is the first priority. This whole thing as second priority. This is the third, and this is the fourth. For this chiral carbon, the priorities are shown like this. 1, this whole thing has 2, this is 3, and this is 4. The priorities clockwise, anti-clockwise rotation are shown here. 1, this whole thing has 2, this is 3, and this is 4. This is known as 1, 2, 3, clockwise direction. But what happened really? It is yes. Similarly for this chiral carbon 2, highest priority is OH, and these biggest group is second priority 2, and this is 3 methyl. So when the Iborg moment comes from here to here, that is clockwise direction. We are expecting it as R, but actually we are getting as yes, because the lowest priority group is in the horizontal line. And here I thank you all for viewing, for observing with patience, and for learning the RS configuration enthusiastically. Thank you all. Thank you.